Hello. In this video we will develop a cluster test. That is a test that checks non-boundary scan parts using boundary scan pins. And we will do it by specifying a test name. For example, switch. We're going to call this switches because this test monitors the activity on some switches on our target PCB. Next, we will copy the settings from an existing test, one that was developed in a previous tutorial, and that was the interconnect test. So by doing this, all of the settings for switches will be inherited from the interconnect test. When switches is opened, we can notice that the chain has been defined because it's the same as the interconnect test, and other items have been defined as well. So if we now go to the cluster page, which is where cluster tests are set up, we'll notice that we have a model, a test model. It's called DTS, Digital Test System. That is the model, and we're going to assign it to location U1, which is the FPGA on our board. Normally we would assign it to a target device like a memory part or whatnot, but in this case we're going to directly connect up the pins to scan pin, the switch pins to scan pins on the FPGA U1. We want to take a look at the model itself. What we have is a header section, and in the header section, scan pin positions, for example U1, pin U4, pin V3, are assigned to names that we're giving the dip switch positions, SW1, SW2, SW3, and so forth. And then a pin group can be defined, which simply collects all of the names we've given to the individual switch positions, and we're calling that pin group SW. Some variables can be defined, which are going to be used for flow control in the program. There's a main section. This count fails off instruction is useful to put at the beginning of DTS models because what it does is it turns off the internal ontap diagnostics that are used for interconnect tests. And the diagnostics in this case, and usually in a cluster test, are developed and managed by the DTS model itself. The instructions are easy to follow. Variable X is set equal to 1. Input disconnect is a built-in instruction, so we're setting the SW pins, the scan pins that drive SW, we're turning them off. We're tri-stating those. And then we're doing a while loop, so while X is greater than 0, let's start it at 1. We're going to do this body of instructions. Output low, another built-in instruction. We're going to test, output low is testing whether the output at this switch position is low. It's assigning that value to Y, and then it's saying if GPIO dips SW8 is high, we're going to put a message out that it's high. Else we're going to put a message out that it's low. Next, an output group instruction will measure the values at SW. So it will read back the values from the switches, and it will do user response equal message pause. So this provides an option to get out of the loop depending on what the operator says, and it will also report the value on switches. So this is the syntax that's used to make up a message. And if the user responds negatively, we'll post this message and exit. Otherwise, this loop will continue. And we'll take a look at how it executes on the test screen. So that's basically the model. So what we'll do is we'll go back to the cluster page, and we're going to assign the scan pins. And when we do that, the header section will be red, and ontap will assign the DTS pin, or the test on the switch, to the particular scan pins that we want. And we notice that there are 0 syntax errors. So we're now ready to go on. The cluster page is set up. Click OK. We do have a warning, but it's not a major warning, not an error. So we'll go on. And on the test gen page, we notice the test plan, which we discussed at a previous tutorial, is set up so we have a state reset, we have a tap test. It's always a good idea to include a tap test at the beginning of your test, so make sure your tap infrastructure is working in order to perform the cluster test. We don't have register segments in this application, so we'll turn that off. And then the cluster page test is automatically selected. This is all being run from U1, so we could change some of these opcodes by simply coming over here and modifying them, but for now we'll leave them all at X test. It won't cause any problems. We finish with a state reset, and we are ready to compile a test. So that's working away, and the test generation is completed. So let's go to the test screen. And here's a previous model that we did, interconnect. So now we're going to just run switches and see what happens. Okay, so while we're running switches, it's showing a message. Here are the tap test results, but it's showing a message that switch 8 is low, and switches is the whole pin group is equal to 0. Let me set some of these switch positions, see what happens when I do. Okay, I set 3 switches, so we have a hex 70. And if we look over here, switch 8 is still low. We want to continue, yes. We'll flip some more switches. And now the switch position is high. So we'll just, and it's hex F0, so 4 switches have been set. So that's basically it. To run the cluster test, we can break out of the loop by clicking no. But just one more thing, back on the development screen, we go to cluster, just to take a look at a different type of model, one with a little more to it. Let's take a look at this SRAM model. And in the SRAM model, notice that the header section is comprised of just the pins on the SRAM device. So we just say pin F3 is DQA1 on the SRAM device. The reason we only need to do that is that ontap will look at this pin on the SRAM and look at the net list and see where it goes, what scan pin it connects to, and it will automatically match them up. You can also have external pins where you assign the locations that you want. In this case, we're using direct IO, GPIO, from port B, and we don't really need to discuss that at this point. Again, we can have pin groups, DQ, data group. The data bus is comprised of all of these data bus pins. The address bus is comprised of these address bus pins. More variable declarations. We're declaring some subroutines, write data and read data, which can be called in the test. And then notice there's a main section. There's an input low where we're driving a chip enabled low. IH is output high, input high. We're driving the, and this is relative to or centric to the device under test. So this is input high to the output enable pin on the SRAM. Notice there are some for loops setting values in an array, an integer array, more for loops, just to show some of the things that can be done in terms of controlling, manipulating, driving, and sensing pins on the board. Now we're calling the write data. The data has been set to the value I as we loop through this for loop. And now we're iterating through retries. We can retry a test. If failures have been detected, they can be logged for diagnostic purposes. And there are more instructions, but just to show you what the subroutines look like. Well, first of all, there's an address bus test where we're walking a 1 across an address bus test, and it's done by using a loop. For example, bit equals 1 to 18, and then the control value row, depending on the row that we want to test, is left shifted. We set row up to 1, so each time we go through this loop, we left shift row, and then that gets set to the address for the data, whichever we want to do. And as we go through here, we'll see a procedure write data, which is called. And here is the procedure to implement the write data protocol on the SRAM, and the SRAM protocol to read data. So that's kind of a brief overview of cluster testing in ONTAP. Thanks for watching.